Hello, welcome, welcome, welcome. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm so excited for today's session. I'm your host. My name's Whitney Lee. I'm a CNCF ambassador and I'm a developer advocate at Tanzu. So here at Cloud Native Live, every week we bring new presenters to showcase how to work with cloud native technologies. We'll build things, we'll break things, and we'll answer your questions. Today, as you see, we have Barun Acharya here with us to talk about securing the secrets manager with KubeArmor. So, this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So, all that means is please be nice. Be nice to the other folks in chat, be nice to Barun, and be nice to me, please. Uh, you don't have to be that nice to me. Just everyone else is important. Friends who are joining us live, will you please put your name in the chat and where you're joining us from? I love seeing that this is a global community. I think it's the coolest thing. And I think that's all. Oh, here's what I want to say. If there's questions, if you have questions during the presentation, please do ask those questions in chat. We're going to make this more of a conversation. Barun's going to share his screen the whole time and code the whole time. No slides. So we're going to have a great conversation, and we can't wait for you to be a part of it. So with that, I'm going to hand it over to Barun. Barun, introduce yourself, please.
Hey folks, I'm Barun Acharya. I am a fellow CNCF ambassador as well,
Love it.
and I am maintainer and leading the development efforts of KubeArmor, a CNCF sandbox project, which we will be diving very deep into today. So look forward to that. I work as a software engineer at Aquinox. Aquinox is a cloud security solutions company, which where KubeArmor as a project originated. So that's all from my
Awesome.
side.
That's amazing. I'm so psyched to have you here. You and I have streamed together before, so this is like a chat with old friends. Are you ready for me to share your screen?
Yeah, give me a second.
All right.
Yeah, I'm ready.
All right. Here we go.
So I think it's loading.
While you're going to do that, I'm going to say quick hellos to all the folks in the chat. We have friends here from Palestine. We have Dallas, Texas. We have Vancouver, Amsterdam. How cool is this? We have Germany. And I don't know where Sherry Povitz is, but hello, greetings. Thanks for being here. Awesome.
Yep. So hey folks from all over the world. So I'll start with introducing KubeArmor to you all. So KubeArmor is a cloud native runtime security enforcement system that helps you restrict behavior such as process execution, file accesses, networking operation. And this happens inside containers or your virtual machines themselves. It could be either on Kubernetes or your bare metal virtual machines as well. So KubeArmor is not tightly coupled with Kubernetes, but it can help you enforce things on containers running on directly on your virtual machines or the virtual machines themselves. But you might ask, what kind of enforcement are we talking about? So for that, what I'll do is we will dive directly into the getting started guide here. Before we actually try to secure the secrets manager, I just wanted to like have a brief introduction that how what exactly is enforcement and how does KubeArmor go about that, because runtime is something very new in the ecosystem, and it's crucial that we understand what's that before we actually try to use protect our secrets manager at runtime.
Excellent. Will you zoom in a little bit on the webpage, please?
Yep.
Thank you. Excellent.
So this is the KubeArmor getting started guide. And as any other tool, you can use Helm to install KubeArmor. And it already shows that, okay, KubeArmor already exists. It's going to fetch all the repositories and do the installation as needed. And we can see that KubeArmor is, yep, KubeArmor is running in our KubeArmor namespace. And if I run KubeArmor Pro, so KubeArmor in general, we are using Helm to install it, but we have an helper utility called KArmor CLI, which helps you dive, like get into, like it's a user friendly way to interact with KubeArmor. In general, KubeArmor has many, like it is Kubernetes native, so you can use CRDs, you can integrate it with Loki, Grafana, Elastic, any stack you have to interact and retrieve information from it. But for today's session, we are going to restrict ourselves to KArmor CLI, such that which is one of the easier ways to interact with KubeArmor. So we see that, okay, KubeArmor is armoring up our clusters, and my cluster is a 3-node cluster on Google Cloud Engine, which has container security set to true, and all of these metadata which we are going to dive in today. Awesome. So here we have a sample Nginx application, and I'll go ahead and deploy it. Nginx already exists.
So when did all that metadata get set? Did you do that? Did that happen upon installation?
Yep, these are the default configuration of KubeArmor. So
Okay.
these information are node level information that, okay, Kubernetes has these nodes, and this is the configuration that KubeArmor sees that, okay, I'm running on a
Okay.
kubelet version of 1.2.27, and the
Cool.
LSM that KubeArmor is using is what's LSM. We will dive deeper into it as well. Le-
Cool.
but that's the secret sauce that KubeArmor uses. Spoiler alert. So that's the secret sauce that KubeArmor uses to help you protect your containers and hosts. And all these are default configuration of KubeArmor, which we are able to tweak around, which we will be tweaking around today as well. So since Nginx is already there, we are going to apply a sample KubeArmor policy. This is a sample KubeArmor policy. It's a Kubernetes resource called KubeArmor Policy. You have a name. The namespace is default because Nginx is deployed in default. And we have a match labels here that, okay, let's enforce this policy on any application that has the label Nginx. And at the end, we are going to call it block the execution of user bin apt and apt-get. This is a very interesting policy because you know how package management you should not be executing any package managers in your containers, right? Because your containers always come with all the pre-packaged utilities that you want at the build time. So you know that if someone is executing a package manager in your container at runtime, something malicious is happening,
Right.
and you should be wary of it. But we will have a policy here which will help us with protecting that malicious activity from happening itself. So while that policy applies and the policy is there, I'll try to execute apt deploy slash nginx,
Oh, that's
and
being
this,
hidden when it's on the bottom of the screen. It's behind your name. Can you? I can remove your name. Basically, I can't see your commands
or
when
I'll
you're
do this.
typing on the
Is
bottom
this
line
better?
of your terminal. Okay. Cool. Yeah.
So we are executing in the to the Nginx container and running apt update and apt install mass scan. Mass scan is used to do port scanning and all that, and it's generally something that malicious actors do use to look for open ports to perform their further attack operations. And you see, we got a permission denied. Hooray! The
Hooray.
process itself did not happen. And you might ask, how do I come to know about that this was done in my cluster or not? So we have logs for that. So KArmor sends out telemetry information that something like this happened. and I will violate it again for you.
I'm on the edge of my seat. I'm so excited.
Yay.
Yeah.
So we have the alert here. KubeArmor says that okay, something happened in the host. This pod name was Nginx. There was a container. You have all these metadata that helps you identify which was the container where it happened. And finally, it was that okay, app denied to certain reasons. You may or may not need this information, but KubeArmor has that entire context so that any like security operator realizes that okay, this has happened and I can take further actions to do that. Okay, probably this container is compromised and I need to take further actions, but the action itself was denied then and there. So I have a peace of mind that okay, it nothing unsafe has happened yet, but I might need to be cautious about okay, let's see what's wrong there. So that's what KubeArmor is for you. And I mentioned that KubeArmor uses LSMs under the hood to achieve this. So we have this enforcer mentioned here as BPF LSM. So LSMs are Linux security modules. They have been in Linux kernel for more than 2 decades now. So they are a trusted way to enforce policies on your Linux machine. But so you might ask, why do I need KubeArmor then? So KubeArmor comes into the picture because these LSMs were designed for Linux kernel back then, and the landscape has changed today a lot. We have Kubernetes pods, multiple machines running as part of a single cluster, thousands or maybe tens of thousands containers running inside our clusters. So it's difficult to manage those entities out there. And Linux, the LSMs in general, whatever mechanism they have, they won't have the information that they would have these information that okay, some PID 49696 was denied, but what is
Mhm.
49696 for me? It's just a number for me, right? I need that entire context that where it actually happened, and that where KubeArmor comes into the picture, that I have that this alert with entire context. Another question that people ask is, do I need KArmor utility to get these telemetry? And that the answer is not that's false. Like you can, KArmor is just a utility so that you quickly gain this information, but you can integrate any of your SIEM tools, and we mention it in our docs as well. That we have a guide entirely for the same, that cube it's a generic way that it's in some pods HTTP out, so you can integrate with your Fluentd or Logstash to fetch those logs and push it to Elasticsearch and have that entire ELK, EFK, whatever stack you follow. You can integrate it with that, or KubeArmor exposes it on a gRPC endpoint. You can manually write your adapter to integrate the logs. As well as we support open telemetry, which is a standardized way of exporting logs and traces. So if you are operating on top of open telemetry, any open telemetry related tools can integrate with KubeArmor. So
Cool.
that's
We have a question from chat. Can you discuss the overlaps between the commercial offering of Cytic to KubeArmor? So
that
Cytic is a commercial version of Falco. Yes.
That's it. So, so Falco and KubeArmor are like they target different things altogether. And Falco and KubeArmor both are runtime security engines. But where Falco shines is that Falco is a threat detection in the runtime threat detection engine. It only monitors for what's happening, and it helps you with identifying that something malicious happened and you want to take actions on it. There are automated ways to take action on it as well. Like you can go ahead and kill the container, and all the related actions can happen. But that's still post-attack mitigation. So we talk about that in our getting started guide as well, that differentiation. So essentially, if what happens is, okay, this is a pawn pod that someone did attack your pod, and there was a malicious execution, there was an eBPF event from Falco, there's an event handler, and then the event handler goes in and takes action on pod. But what how KubeArmor does this is that it denies then and there that, okay, this execution itself at level 1 would have been denied, and you would receive all the telemetry information relevant. So that's the power of inline mitigation, that any further containing nothing, like the attack itself is contained then and there itself,
Hmm.
and all the other actions, like, but where Falco shines is that it has a rich ecosystem of integrations, and it helps you with all the threat detection mechanisms. So that's the differentiation overall. I am not sure about what's other offering
The
that Cytic
commercial
commercial
offer.
parts
Hmm.
include, but
Hmm.
yeah, but that's how KubeArmor is differentiated in general, that we go for inline mitigation and help you contain attacks that way.
So inline mitigation is the terminology for when an attack is stopped as it's before it happens. Is that what I'm understanding?
Yes. So as it happens,
Cool.
it is denied. Cool. So that's an introduction to KubeArmor. We already saw that what's the capabilities of KubeArmor. But what I'm now going to do is, let's get on with the topic that we are here for. We are going to secure the secrets manager itself, so that you keep your secrets safe and secure inside secrets manager. But what if some attack happens to your secrets manager itself? And that's where we are going to talk about the problem statements and how we are going to prevent that. For today's discussion, we are going to use HashiCorp Vault. HashiCorp Vault is a secrets manager, very well-known secrets manager, and we are going to go and secure it. So let's install HashiCorp Vault. I think I already installed it, but check it using help. Let's wait.
There's There might be audio. I think we're just quiet. We have someone in chat pointing out that there's no audio, which I appreciate. I would like to know that. But I think we're just quiet and watching Barun work right now. Barun's installing HashiCorp Vault and then going to show us how we can use KubeArmor to secure the vault.
You do hear me, right? Just check.
I can hear you.
Nice. Okay, we deployed HashiCorp Vault here, and let's see if we can access it. Okay, it's still container creating. Let's wait for it to start. While we do that, let me talk about why protect secrets manager. Right? So you might say that anything inside a secrets manager is already encrypted. Why do you
Hmm.
need, even if some attacker comes into my container and tries to access the secrets, what would they get? It's already
Mm-hmm.
secure and encrypted and all that. So I don't have any losses, right? Even
Mm-hmm.
if they do able to access it. But now the issue is, what if they go ahead and delete your secrets? What if they go ahead and add an encryption layer on top of that? Now you yourself are logged out from accessing your own secrets. And now that's how basically ransomware attacks work. That now you need to pay the ransom to get back that access. So uh, where KubeArmor will come into the picture is that it will not let, and even if an attacker sneaks into your secrets manager container, it will not let them delete, add an encryption layer. So all that, it's all completely safe and secure there. And I hope Vault is running now. It is running. So let's try accessing it.
So to do that, Vault's looking at the system calls at the kernel level of the machine that the HashiCorp Vault is running on. Is that correct?
Can you repeat it?
To do this to protect the data in the Vault, what it's doing is looking at the system calls on the machine that the Vault is running on. Is that correct?
Yeah, that's right. That's right. So
Okay.
that's a nice question. That where is KubeArmor running? Is it just a
Yeah.
pod, or is it how does it know that which node Vault is running, and how is it protecting it? So essentially, if you look at the KubeArmor manifest, you see three KubeArmors here.
Mm-hmm.
Essentially this is the main engine that protects your containers, and there's an operator. So KubeArmor uses operator based installation, and there's a relay server which helps you with all the SIAM integrations that we talked about. But the reason you're seeing three KubeArmors here is that KubeArmor installs itself as a daemon set.
Okay.
It's monitoring all the processes on all the actual nodes. So daemon, it is running as a daemon in all the nodes itself, and that's how it knows that, and it has all the metadata to actually go ahead and then construct the
Have
the telemetry that it needs here.
I have a question around that part of it. Looking at all of those system calls on all of your machines seems like it might take a lot of compute. How does the KubeArmor is KubeArmor like a heavy technology?
If you see right now, kubectl top pods, it's 17 M CPU and 100 M memory, so it's using not much, right? Like,
Okay.
it's very decent amount of usage for the kind of things that KubeArmor is doing. And
But
because
you're
how
not
does it do that is,
yeah, but you're also not making a lot of system calls right now, right?
yeah, if show you and Vault itself has started already, right? There are things running. If I show
Okay.
you the cluster itself,
Okay.
get pods
Okay.
A, you
I
will
didn't
see there are a
yeah.
lot of things
I hope
running
I
right
don't
now.
seem
No, 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 that's
contrary.
completely
Okay,
valid.
cool.
So if you see, this is traveling, like lot of syscalls are
Okay.
already happening. And why
Okay.
is it efficient like that? Because KubeArmor uses
Uh-huh.
eBPF and all that, right? So everything
Oh,
is
of
happening
course.
inside
Mm-hmm.
the kernel itself. And because we are intercepting the information right at the kernel level,
Mm-hmm.
nothing. So the overhead is pretty less from what we benchmarked with. Like, it's an opinionated benchmark, but the overhead that KubeArmor adds is less than 3%, and we have published that data as part of Wiki, and that's decent considering how KubeArmor is helping you enforce things here. And monitoring all the syscalls, like as you said, a lot of syscalls are happening right now itself. All the network calls are being reached. But you might ask that what we will dive deep into. Even this is a lot of information, right? And you can choose to configure KubeArmor in a way that, okay, I don't need network information altogether. let's disable disable it altogether. So all that configuration options are all as well.
So it doesn't have to monitor every single system calls. You could say, I only want it to monitor when a file is opened or something like that. And it'll do that.
Yeah, right.
Yeah. Okay. Interesting. We have another question from chat. I just totally derailed your. You're trying to talk about Vault and we're getting into other things. But the question is, what level of kernel exposure / coding is required to make the most out of eBPF offering part?
So KubeArmor itself, as you saw, right, these information that that were coming right now. I mean, this was not formatted, but whatever you see here is all structured data, and you need zero is EVPF experience to get these data altogether. So it's purely how you manage any Kubernetes resource. You are going to manage KubeArmor as well. It's all YAMLs, annotations, labels. That's all the concepts you need. You don't need to write actual EVPF code to do anything. That's the complexity that KubeArmor handles itself. You don't need to worry about that. And that's why you need, like, you don't need to understand eBPF at all. There are some parts, like, you might need to understand, like, if you make a lot out of it, you might need to understand what's process IDs and how to go around. Like, actual protection will be handled by KubeArmor, but do the day two operations, that okay, this attack has already happened, what are the next steps to debug, where in my entire infrastructure actually caused this attacker to sneak in. That's where you might require further, like, to understand some level of like process ID, what's process ID, and all that information to understand, like, go ahead and debug that. But yeah.
We have a nice statement that from Jay that he appreciates our conversation and digging in about, like, there probably aren't many system calls happening. And then we also have a question from Kuldeep. So we're talking about securing HashiCorp Vault right now, but does it make sense to use KubeArmor when we're using a CSI driver to mount secrets? So you could still use KubeArmor to secure Azure Key Vault or to secure AWS Secrets Manager, those two technologies themselves, right? Because KubeArmor is not Kubernetes
part of
specific.
But like, I'm not sure how AWS Secrets Manager will be hosted in their own private clusters, right? So if AWS chooses to do that, I'm not sure if there's a self-host option on these two management solutions. But what you asked is that, like, what Kuldeep wants to know is, the CSI drivers goes ahead and mounts those secrets inside certain pods so that they can leverage those secrets, right? So you can go ahead, you can definitely use KubeArmor to secure those volume mounts themselves. So the secrets that are mounted inside, so that only certain binaries inside a particular like pod are able to access those secrets. You cannot go ahead and cat that secret or rm that secret. So that's there. Yeah, so it totally makes sense, and that's a valid use case. We are actually going to secure volume mounts in Vault as well, but for some reason Vault is not letting me initiate it, so I'm checking that out. So some live debugging is going to happen here.
We promised up top that we'll break things, so we're delivering on that promise. Kuldeep has a comment. I just want to say you're talking about Cytic and Falco. So Kuldeep, you said you joined late. We already talked about that already, so I recommend you catch that as part of the recording. But the short answer is that KubeArmor, we'll see how well I'm listening. The KubeArmor does inline enforcement, which means as the attack is happening, it's stopped before it even happens. And Falco does asynchronous enforcement, where it's the attack happens, the bad thing happens, and then an alert happens, and then some sort of effect happens. But it doesn't stop the bad thing from happening. Falco's still amazing because it's an amazing community with a ton of integrations. There's a lot you can do with it. But that's the differentiator between those technologies. How we doing? Give us a an insight into your world, into your debugging.
What I'm going to do is what's famously done by anyone. I'm going to uninstall and install again.
Very sophisticated work happening here.
It's a complex debugging process, as you all know.
We can all relate. Do y'all have any questions to chat about while we're waiting on this part? Or Brood, is there anything you want to highlight while we wait?
Something one of the thing was that probably these all information are not easily consumable for you all, right? Why are so many JSONs flooding my screen or flooding my databases? I need
Mm-hmm.
something to aggregate for me, right? These are network calls that are happening. Vault is going to make a lot of any application with a liveness probe is going to make a lot of network calls, right? So is there a way that something is aggregated here for me? So KubeArmor has a nice utility called profile, and if I go ahead and run that, I think okay, I uninstalled Vault, so nothing will happen now. But
And
what
you're
it does is what
it's
it will
hidden
do
behind
is
your name. Yeah, sorry.
it will start aggregating counts for the same process that's happening for you. So if network calls are getting executed frequently, it's going to do that and aggregate it. We are going to see it once the vault itself is starting to run.
So when your active line is on the bottom, we can't see it from behind your name.
Yeah, okay. I will have to keep that in mind.
Yes, yeah. Cool.
But I will show you that profile using default namespace maybe while Vault is installing. So
Love it.
we did Vault, right? And we did apply a policy on an Nginx, right? So I'm going to do apt again. So, okay, apt was permission denied 2 times for me. The result was permission denied, and the
Ah,
bin bash process was executed once. And I have network calls were made by Prometheus, sidecar injector. All these are getting aggregated for me. Okay, this has happened 18 times. This has happened 6 times. So all that
okay.
metadata is aggregated for you here.
Cool. And then all that's also getting sent to like via open telemetry to whatever
Yeah.
your stack is. That's awesome. We have a question. We have from Jay. Oops. Um, so this is a tangent if we need questions to kill time, says Jay. Y'all mentioned BPF LSM enforcer. Is AppArmor LSM also an available enforcer?
Yep. So KubeArmor uses, and like as I said, LSMs under the hood, and the project actually started out with KubeArmor using AppArmor as an enforcer, and we pretty
Ah,
much have first class support for AppArmor. It's because if you see today, AppArmor is being used quite heavily because AppArmor also integrates with pod security context in
hmm.
Kubernetes. So people do use AppArmor to protect their applications, and they do it at some level. But writing AppArmor profiles themselves is hard. So that's where KubeArmor comes. That entire narrative that why KubeArmor is needed. But why we are betting more on BPF LSM is that because BPF LSM we are writing our own code to decide what is being enforced instead of translating our policies to AppArmor based profiles. And there will always be limitations in AppArmor provided, like because another tooling, right? We can do only so much there. So we were being limited by what AppArmor has to offer. And so that's where we are today, like if we say BPF-LSM and AppArmor have achieved feature parity, so any of the both of them you use, it's equal for you. But as KubeArmor progresses, we are going to add additional features which can leverage the powers that BPF-LSM provides us. So that's. I hope that answers your question.
I can't see your command line over there. It's behind your name. Yeah, thank you. I tried to look into just taking your name off the screen and I was having trouble with that. I can try to make it into an X. See if that works. No, it does it on both, not just you. Okay, I took your name away. I'll put it back. Oops.
What's happening is that for some reason I'm not able to initialize vault, but we can still try and go ahead and secure vault, right? Based on what's happening. If and this is a good time to launch KubeArmor profile.
That the policy wrote only applied to like Nginx things. That wouldn't be the thing that's causing Vault to fail, would it?
No.
Okay.
No, what's happening is Vault is saying that I'm already initialized, but then the UI shows that you need to unseal me. I'm not initialized. So I'm not
Okay.
sure why the command
It's,
line thinks that I'm already initialized.
got you.
You see, so as I tried accessing the UI itself, I'm seeing that Vault has certain processes getting executed here, right? Bin busy box is executing Vault status, bin Vault is spawning Vault status checks. Vault itself is performing some status checks. So all that execution is happening around Vault as it runs. So, and that's getting aggregated here. And file visibility itself is on as well. That inside my vault directory, okay, home vault is getting access, etc password keys. Some of these are security sensitive files that are getting access frequently, and then itself vault is having some network calls altogether. So that's how KubeArmor is aggregating it all for you. But you might say that this is a lot of information, right? And you see file accesses are already happening at much faster rate. There is 23, 16. It's increasing very fastly. And I wouldn't want that. Even network, right? This network is already reaching 86 on my aggregated while it only just started. And that's not like you might say that that's causing some performance overhead as well. What I'll do is now we can modify what all you want to monitor inside a particular namespace. So if I go ahead and describe vault, ns vault, everything is installed inside vault namespace, right? You see KubeArmor, I have an annotation here saying KubeArmor visibility, process, file, and network. So these are the three entities that we are monitoring using KubeArmor. By default, it's just KubeArmor process and network. I had added file explicitly so that we show that, I could show you this nice view that, okay, what's happening inside. But if I go ahead and override this annotation, annotate ns, and go ahead and set it to none, it will just stop increasing now. Nothing inside the vault namespace. It will get stuck at 151. It was increasing for you a lot of time, but now it's not going to happen. And if I go ahead and KubeArmor logs, log filter all inside this vault namespace, even if I now execute anything, suppose I exec and keep this in, and it vault and sh. Okay.
I can't see what you're typing down there.
Sorry.
Thank you. It's okay. We need a secret word. Jelly beans.
So all these accesses I'm making, but I don't have any logs yet. But I will go ahead and now annotate again, and I'll just now have process annotation. I only want to get alerts for processes. And now if I go ahead and do an ls, voila, I am only getting process based executions now. So you can fine tune what you want to receive inside. Like I know that, okay, I already know what all processes are going to happen inside. But the nice part still is that even if I now apply policies and visibility is off, QArmor is still going to enforce and alert me when something is violated. We will try that out right now.
Cool.
What I'll do is, we already tried out, you might say, we did a getting started guide, right? And we saw a sample application that I had, a sample policy that I had in getting started guide. But I want to, as as a user, I don't know what all policies do I need. How do I know how do I know that package management execution is a bad idea? I do I need to educate myself with all that and uh, all that things, but you actually don't need to. We have a community, uh, mm, uh, like community maintained repository of policy. It's called policy templates. So community maintained policies for all of you, such that you can explore here, but going ahead modifying each selector for individual application here is going to be hectic. So that's where KArmor shines again for us, and we are going to run KArmor recommend me policies for my namespace Walter. So I'll just go ahead and run this.
So it's looking for the community
Yeah.
policies and seeing which ones might be applicable for your particular namespace.
Yeah, and
Cool.
also it updates it, like, so like I had last time, I guess I asked it for recommendation was maybe 6 months back. So the
Okay.
current version was 0.2.3. It said me that, okay, new version is available. The community has much more policies now. I will update it for you, and then I'll generate it all for you. And I have a report for that. I I will reduce a font size a bit so that you can see the full report and zoom in accordingly. But here are all the policies that the like that we have in policy templates, but it's tailor made for your application now. So I had two pods in. One
Cool.
was the agent injector, and one was the vault itself. And I have all these policy that have CIS command line warming and impair defense. These are based on certain frameworks out there like CIS, MITRE, and NIS. These are all the compliance frameworks out there which security
Oh,
organization
cool.
help use to like have compliant products. And KubeArmor can help you achieve compliance using these policies. So we will try one of these policy out. Say that
I have I have a question.
any
I have a question. So say I want to apply one of these policies, but I already have my application's already running in production and I don't want to break everything. Can I do this in like an audit mode or like some sort of monitoring mode to see whether the policy is going to break my application or how I might need to change my application, and then apply the policy for real?
definitely. So
Okay.
what I'll do is, so there are two. So like essentially, KubeArmor supports three operations
Uh
that
huh.
you can provide in a policy. One is allow, one is audit, and one is block.
Okay.
So
Okay.
what we are going to do was block access to certain things, But what I can do is I can run it in, keep it as audit policy and
Okay.
monitor if something is happening. So let's do that right now. So this is not allowing writes inside. We already see in Vault that etc password t was accessed by Vault, but that's a security sensitive file system. No one should be able to modify it.
Uh-huh.
And so what we are going to do is we are going to disallow anyone to modify anything inside etc directory. So
What's the
let's
use
do
case
that.
for allow? Why would you do allow?
Allow, yeah, I tried to sneak that. I tried to sneak out of that.
Sorry.
And no, that's fine. But because that's the next part that I would have done after we would have tried that out. So
Okay,
allow
okay.
is
Get to
basically,
it. You can get to it when you get to it. We can have some
yeah,
suspense. You don't have to answer me right now. Okay. I like that.
yeah. So no spoilers yet.
Okay.
Let's say that. So allow is very powerful and it's difficult to tame as well. But I'll keep all the spoilers once we try out these basic recommendation policies.
Okay, sounds good.
So name of my policy was write and etc write etc directory, and I have this policy and I will edit it for you. We had block set here. What I'll do is I'll audit it first so that we know, you as you said, it might break my system, right? So I will just
Mm-hmm.
set it to audit here and kubectl apply f, and the policy itself is live and exec. Just a quick point, because we say so as I said, enforcement works even if you disable the visibility, right? We talked about disabling visibility just a while back. But because we are going into audit mode now, audit us to enable visibility if we try to audit, because audit is something which is not like that's happening. That's a KubeArmor feature. It's not something which is happening inline. So we need the visibility set to true when we want audit to work. So I'll enable file and network back again so that the audit policy itself starts working. And cd etc ls. And what I will do is I will create a file now here. Okay, that's weird. I guess I did not change it to block, change it to audit.
So that permission was just denied because you have a policy in place that a file can't be created in that namespace.
Yep. Okay, let's check the policy once. We do have it in audit mode. Is it vault? Maybe that.
While you figure that out, I'm going to answer Luca's question. Maybe you can back me up. What are the best practices for managing sensitive application information in a containerized environment in a standard way using Vault and KubeArmor correctly? For example, if you had to deploy a Spring Boot application via CI/CD pipeline on Kubernetes, how we have it, it's longer. Um, how would you manage its application properties with Vault? For example, pass them necessary information such as user, password, database connection, etc. Would you use config maps, environment variables, or anything else?
I
Yeah.
I think that's a problem that's handled by Vault itself.
Yeah.
Vault Vault provides an encrypt like an ideal way, both by Vault as well as Kubernetes has a secrets operator which handles all this complexity for you. That secrets are exposed in the correct way inside a particular, so that your Spring Boot application here can access it out. What additionally KubeArmor can help you do is that wherever secrets are mounted, with be it environment variables, config maps, or volume mounts themselves, KubeArmor can go ahead and secure them all together. So they work together to secure things here.
So KubeArmor is securing at the system call level, and to be specific about Vault integration into Kubernetes, like it can be done directly, but there are a couple of Kubernetes projects that help you do it. And one is called External Secrets Operator, and that one will reach out to your Vault API and then store the secrets you need as Kubernetes secrets. The other one is called Secret Store CSI Driver, and that one reaches out to your Vault and gets the secrets that's needed for a particular application and mounts it to that application pod as a temporary file system volume. And in both cases, KubeArmor can help secure at the kernel level.
That's right. What's happening here is, I guess, something inside the Vault configuration is blocking it here. But as we can see here, accesses are being made to Vault. So probably a bad, and it is working correctly because it's in audit mode. So as you said, if I would have applied this as a block policy, my Vault application could have broken down. So using audit mode to monitor that I have zero alerts first is a good way to understand that if my application is going to break or not. My application is still safe because it's in audit mode. So that's where, audit and block mode shines. What we will do is, so that was the community part of it. Now let's dive into what's the allow thing that I kept secret for so long, right? Allow is something which. Sorry.
I was going to ask you to zoom in on this terminal if you're going to use it.
Yeah, I'm just going to do that.
Cool.
You see, because so many of it was getting executed, it said that, okay, just go. The binaries are now, a lot of binaries inside bin are getting executed, so they are aggregated already. But
Nice.
that's something that profile is doing for you. The logs themselves are all as they should be, and
We make it bigger.
you get both kinds of information.
Thank you.
Sorry. So
Yeah, great.
this is still the full information. And if you want the summarized information, you have it here. So that's where. But let's do one thing. I would want the full information just for some context. So while this loads up, what was allow policy, right? Allow is something, zero trust is something that we have like a lot. It is being talked a lot about in security, especially in cloud native security. Even if I go ahead and apply this policy templates, these are only helping me prevent against known attacks that these frameworks have like analyzed and created policies for me. But what about the unknown attacks? What if something happens which is not covered by these policies? There are only so many things you can go ahead and keep blocking, auditing. That life cycle is going to be tiring for you. So that's where the allow policy comes in the picture. You can have zero trust policies created and enforced by KubeArmor. So what's a zero trust policy is that I don't trust anything inside my container. What I want to trust is that, okay, I know that, okay, this is getting executed. Bin vault, bin sh, bin busybox
Ah.
is getting executed.
Uh-huh.
I'm just going to trust that. And anything else that gets executed, no, I don't want it.
Ah.
I'll
I
deny it.
see. Makes
So
sense.
that's allow policy. But as I said, it's hard, right? You never know. Okay, bin vault execute. I only saw bin vault earlier, and I created a policy saying that only allow process bin vault and deny everything else. Now, as soon as bin busybox get executed, my application is going to break, and that's where
Mm-hmm.
again audit mode is important. Uh, we'll see how we do that, and let's create this policy. I will write. I'll What I'll do is I'll just cp into zt.yaml, and let's vim. So I'm taking this as a base policy so that I have all the required things. Vault zero trust. Action is set to block. I'll change it to allow now. And as I said, let's say that, okay, only bin vault is allowed to access, nothing else. So match path, and I'll say bin vault. This was bin vault was a process that we saw here. So I'll add this and alert untrusted execution detected. So that's my final policy, saying that I only trust bin vault. Anything else, go ahead and deny it. So CP, and so we have this policy. I'm going to apply it, and right now it should have broken it, but it will not break because by default KubeArmor keeps them in audit mode. Okay, I missed something out. So okay, read only something specific to file constructor processes. So I have the updated policy. Cool. So zero trust policy created. And if I go ahead and even executing sh is already something which happened, right? And cube, I guess kubectl get ksp. I'll delete the earlier policy. And if I execute ls here, okay, I have a audit alert saying that bin busybox got executed. Ls is part of the busybox binary. Bin busybox is being executed. It's something that you should look into, that probably your application still, the zero trust policy is still not complete because you are receiving alerts, right?
Uh-huh.
So take this and probably go ahead and add it. So I'll go ahead and add bin busybox now into the policy.
So is this a normal framework for profiling an application and monitoring it and then figuring out how to implement zero trust
Yeah, like this is what's
process?
the core process of it. What I'm
Mm-hmm.
doing is it in a very primitive way. There
Mm-hmm.
are two. there are commercial toolings out there which do it in an automated way. Or what you can do is you can dump all the logs into some database or Elasticsearch, Loki, and all that, and have that entire
Ah,
profiling done and done from there. So a lot of
that makes
things there.
sense. Mm-hmm.
This is because I'm doing it in much more different way, because I just
Okay.
wanted to show you how at core level this works out.
Love it.
So now I've added bin busybox,
Mm-hmm.
and I executed ls, and I did it not. Okay, I did not apply it. Configured, yeah. So I did not apply it, neither.
Got excited.
ls, and okay, no alerts yet. So ls is an expected outcome now. But let's check
Excellent.
if there's anything else I can use, which is not busybox here. Everything is busybox.
Everything's BusyBox.
But since file operations are allowed, I will be an attacker and copy vault into and rename vault into something else. Let's say test. Okay, I'm permission denied to do that already by KubeArmor. That okay, no, you cannot do that. So I guess I'll just ask you to trust me on this and say that if any other process is executed, it's going to be denied.
You're ironically asking us to trust you about zero trust.
Okay. Oh, no,
Remember,
I have some processes. Yeah.
okay, great. Yeah, show us.
And let's see. Uh, LDD, right? LDD got executed, and I got the alert saying LDD was executed. But it is something that should not have been executed. So I will go ahead and annotate my namespace saying let's set file posture equal to block. Now anything related to processes and files are going to be blocked inside this.
Hmm.
And you see LDD is permission denied, but all my processes like bin, busybox, and vault are working as expected, and my UI would be working as well. So that's how you have that entire zero trust policy lifecycle management for you, that you can set it in audit mode per namespace and change it to block mode when you see, be confident that this is going to work.
Awesome. Can you
You
believe
were
an
saying?
hour? I was going to say an hour's passed already. It's flown by. I feel like I could do this all day with you, but we only have this hour, and I think maybe you covered a small fraction of what you hoped to cover, but we just asked you a lot of questions. So I hope that you come back on soon and do some more with us because this was super, super fun. Is there anything you want to say in closing before I read the goodbye script?
So, but I already covered most of it, and now I'll
Okay,
just
good.
add one pointer that I only did it for processes, but you can do this for file systems, like how we were talking about entire securing the volume mounts and all that. You can define which you can fine grade it at level that I can say which mount is going to be used by which, and I'll just show the final policy there so that you have an idea what it would look like. I'll say that okay, vault is a volume mount inside vault. Lot of vaults inside. So inside vault, I'm going to block accesses to the vault itself and allow this vault access to only bin vault binary. We already see bin vault binary, right?
Ah, mm-hmm.
And similarly, and this is something which we already discovered, right? Bin busybox and bin vault. So this would have
Mm-hmm.
been the next part where we would have secured the volume mount itself. But now we already know the core concept of it, that how to go ahead and generate this policy. And you have that entire life cycle management of audit and blocks so to help you out. So, yep, that's all. We covered a lot of it,
We
and
did.
hope you all use KubeArmor. You start using KubeArmor to armor up your clusters now.
Where
Have that
should
shield in your
folks
clusters.
where should folks go if they have questions after watching this video?
Sure. So KubeArmor has its own Slack.
Okay.
You can join us. This is kubearmor.io.
Mm-hmm.
We have a nice gopher here with a shield to help you protect you. And you can join us, go ahead, use on GitHub. We have discussions. You can go ahead and ask questions there, create issues. That's one way of doing it. Or you can join our Slack and ask us questions there. We have an active community there helping out everyone who is wanting to know how to start things here. So yeah.
Awesome. I appreciate you so much. And I appreciate all y'all in chat for asking great questions. Thank you for that. So, thanks for teaching us about KubeArmor. And here at Cloud Native Live, we bring you the latest in Cloud Native code on Tuesdays and Wednesdays, so at the same time of day. So, thanks to you for being here. Thanks to Brood for presenting. Thanks to everyone who watched the recording. And please join us again next week.